In trigonometry, you learn a lot of different identities. Some of them are useful for generating a lot of the others. So I tell my trig students, don't try to memorize every single formula. Memorize important core ones like the angle addition formulas. Sine of a plus b, sine of a minus b, cosine of a plus b, cosine of a minus b. That looks like a lot, but if you look at the pluses and minuses, it just boils down to two formulas. If there's a plus sign here, there's a plus sign there, and a minus there, a minus there. And these are opposite. If this is a plus, that's a minus, and vice versa. I wrote them out separately because of what I'm going to do next. We're going to make the product to sum formulas. If you take sine of a plus b plus sine of a minus b, when you add those together, these terms cancel and these terms double, so you get 2 sine a cosine b. When you take cosine formulas and add them, these cancel, and you get 2 cosine a cosine b. And if you subtract, order matters, this one minus this one, cosine a minus b minus cosine a plus b, you get 2 sine a sine b. What this is useful for is in situations where you have one of these and you don't want to deal with them. It's like, I don't want a sine times a cosine. I'd much rather have a sine plus a cosine or something like that. This is a way to turn products into sums of trig functions, and vice versa if you want to go the other way. This gets used in various places, such as Fourier series, showing why the Fourier series works. If you have to integrate these expressions, these aren't that bad to do. You can integrate them by parts a couple times, but if you know that you can rewrite them like this, depending on what you're doing, those might be dramatically easier and faster to deal with.